So hello, I'm very happy to be here today. And as Sabina said, I'm going to talk to you about building your own network stack. Swift has a lot of these powerful tools that we can use, such as codable protocols and generics, as well as our friend URL session. Before I get right into the talk, I guess I'll introduce myself a little bit. I'm Glenna, and as Sabina said, I am a software engineer at 8fit currently. I'm from the US, but I live in Berlin, which means 8fit is also in Berlin. And actually at 8fit, in case you didn't notice, Sabina said iOS and Android engineer. I'm actually doing React Native. Okay. Actually, originally I had a slide after that was like, I know. But I removed it. So actually, if you've ever done React Native, I would love to talk to you. But I'm happy to say that this talk is only about Swift, or in Swift. And I've actually only been doing React Native since April. Okay, so the agenda for today, what we're going to go through. Yeah, but why? Networking is not exactly the most interesting topic that I could have chosen to talk about, especially we're living in the world of machine learning and AI and ARKit and all of this stuff. Then I'm going to show you my naive approach, and hopefully no one laughs or throws things at me, of how I would approach like a URL request if I was just getting into Swift. And then I will introduce you to a few different tools that I've used in the past that helped us in a previous company build a network stack. But of course, I'm not going to tell you what they are now, because that would spoil it. Okay, so the motivation. Why am I talking about building your own network stack? This gets into a little history about my software career. Up until about a year ago, I would have considered myself something of like an Objective-C dinosaur, because I had only been doing Objective-C development since I became a programmer about 7 or 8 years ago. And at that point, Swift was, I don't know, 4 or 5 years old. And I was looking for a new job at the time. And so this time last year. And switching from Objective-C to Swift, I would say, is pretty easy. But when you're applying for a job and you have no Swift experience, it can be a little bit challenging. And so all of these job interviews had these code challenges, which I'm kind of not a fan of, but that's beside the point. And all of these code challenges happen to also say, feel free to use whatever third-party framework you see fit. And I found this to be like a very inhibitive thing for me whenever I was working on these code challenges, because I hadn't actually been in Swift development. So it was hard for me to weigh the benefits of using one framework over the other, of using a framework at all versus not using a framework at all. And then when you Google, oh, best Swift networking frameworks, or best Swift blah, blah, blah framework, have you seen what comes up? There are so many Medium posts that you can find about the best networking frameworks in Swift. Most of them are super outdated, but still, there are a lot of choices. And at some point, I just decided that code challenges weren't worth it, so I didn't drag any third-party frameworks into the mix. Fast forward a few months later, and I was working at a company called Coop, also based here in Berlin. And they're actually like an e-mobility sharing service. So there's these scooters out on the street that are pretty nice. And this team was actually a perfect fit for me as I was making the transition from Objective-C to Swift, because the configuration of the team at the time had this kind of mindset of kind of going back to the basics. We barely had any third-party frameworks at all in our code base. And at some point at Coop, we needed to support a second API service that would serve for an internal tool that we were working on at the time. And I was the lucky one voted to upgrade our network stack to support this second API service. And that is kind of how this talk is born, because I really loved when I was working on that network service. And I learned a lot of cool things that I think I will share with you. Okay, so now I'm going to show you the naive approach. And my naive approach, this is what I would do. But before I start with the examples, I kind of have to preface what kind of the examples are going to be based on. I've been reading a lot lately. I think I'm on my 15th book of this year. So that kind of helped influence the fact that I decided to use the New York Times Developer API. Specifically, we're going to look at the bestsellers category list. But also, I have to say that it's because the New York Times Developer API has a low barrier to entry in terms of making a request. And that kind of just means that you just need an API token or an access token. You don't need to do any OAuth kind of stuff. And so for the purposes of this talk, that was what I needed. OK, so the naive approach. Let's start setting up. As with any request, we usually start with a URL, which of course we usually start in string form. This is just a standard URL GET request. And from that string, we need to make an actual URL. And from that URL, we need to actually make the URL request. And then after you have the URL request, you can set any specific properties that you need to for that URL request, for instance, the HTTP method. OK, so we have a URL request, but we haven't even done anything with the network. And that's already 4 to 5 lines of code. That's quite a lot. Now let's make our network request, and that's where a URL session comes into play. And I'm pretty sure, I guess this will be familiar to a lot of us. But yeah, we'll use our friend, the data task, and we'll get a data task. And then we'll, with the data response and error and the completion handler, we'll handle if there's an error case, or if there's data, then we'll do something fun with it, probably decode it, because that's what we have to do. And then, because I always forget to actually execute the data task, I made sure to put this as an extra highlighted step. Don't forget to execute the data task. OK, so now if we look at all of that together, just for the naive approach, it's I don't know, there's a lot going on there. And it's not, I would say it's not the cleanest code that we could look at, and it doesn't look super Swifty. OK, so now that we've seen kind of the base approach, I want to start introducing you to a couple of the tools that I find really helpful and that I like working with whenever I was working on the network stack at Coop. OK, so the first thing I want to introduce is the API router. And it's not a coined term. I don't even know what, I wrote it like a class name. But yeah, it's actually pretty simple. It's just a protocol. And from that protocol, you can get a URL request. And my favorite way of implementing the API router is actually via an enum. And there are several reasons for that, but I'll try to point them out as we look at the code. OK, so first you have one specific request, so you make that one of your cases. And in this case, we want to fetch the bestsellers category list. And of course, to conform to the API router protocol, we need to generate the URL request. And you'll see in this code that there are actually a lot of variables that you don't see in this chunk of code. And that's because that's why I like to use enums. And you can have computed variables on the enums, which we'll see on the next slide. Yeah, so this is basically the same thing that we saw in the setup before, except I have added a HTTP header field, I think, and potentially some body, some data. OK, but now it's really nice whenever you have these computed variables, such as route, because all of these API requests have different routes. It's also really nice when you can have a computed variable for the host, but that's usually switching on the environment. And then, of course, HTTP method, HTTP body, et cetera, et cetera. OK. Yeah, I really love this way of using enums. Maybe I'm the one. Maybe it's not the way they're intended to be used, but I really like it. And then, in addition, it's really easy to add another request to it. So you just have another case. And then it's really nice with associated values. You're able to pass any data that you want to the API. Or for instance, in this case, I think it was used as a query parameter, so that date is used as a query parameter. Okay. Now, if we look at the call side again, now we just have we get the URL request from the API router, and then we have the same data task where we look at the error and the data after we've executed it. I'd say we've cleaned up a little bit, but we still don't have data in any usable form. It's not super Swifty. So the next thing I want to introduce to you is the kind of a rudimentary network service and network operation. Okay. All right, so for the network service, what I really want to hit home here is that it's pretty much a wrapper around an operation queue from Foundation. And so you have the operation queue, and then you have a function to add an operation to that operation queue, or in this case, to add a network operation to our network service. And I will get to this network operation protocol in a little bit. All right, so that looks pretty doable. And now we're going to get to the network operation, which has a little bit more meat to it. Okay, so now we have a network operation which inherits from Foundation's operation class and conforms to this network operation protocol that I alluded to earlier. And it's pretty simple. It just has a request and a completion handler, which has optional data or an error on success and failure case. And then you can initialize it with an API router because you can get the URL request from the API router and a completion handler. Then we have this perform request function, and that will have all the meat of this class in it, all the heavy lifting. Then we'll have some operation class overrides, and then we'll have some the conformance to the network operation protocol. Okay, now we'll take a deep dive look into the perform request function. I'm pretty sure we could all guess what was going to go in here. So we're back to our data task friend. All the same setup, except this time we're going to turn the data response and error situation into one of either result.failure or result.success and return it in and call our completion handler with it. And I'm not handling HTTP status codes, but you could feel free to do that, but that ends up kind of bulking up the code on a slide. Okay, so that looks pretty good. Now, I don't want to be hand-wavy, so I will show you this network operation protocol and try to explain what it's doing. I would say it's something that we used that kind of made operation a little bit more Swifty. So in operation, you have state, or you have functions that you need to override to let the operation queue know if it's ready, executing, or finished. So we made this enum so that we could easily calculate if they're ready, executing, or finished. Okay, so now if we look at the call site, we can just pass in the API router into network operation. Then we get our lovely switch on result back, which we're probably all working with all the time. So if there's data, do something with the data. If it's a failure and there's an error, do something with the error. And then we'll add that network operation to our network service. Okay, this is already starting to look better. It looks like we're back into the Swift world and not still in some Objective-C completion handler stuff. But we still don't have data in any kind of usable form to our application. So I'm sure everyone's going to guess what's coming up next. Yeah, so the next thing is to genericify everything. But mostly we just care about genericifying network operation. So now the network operation class looks like this. It's a network operation of type T, where T is decodable. And then, of course, the completion handler changes, where you're returning an optional T type in the success case, and still an error in the failure case. And then our perform request function gets a little bit heavier. Yeah, so let's take a look at that. Okay, again, we have our data task. But now it starts to get a little bit interesting still. If there's an error, we're just going to call our completion handler with the error. But if there's data, now since we know that T is decodable, it's pretty easy to just use JSON decoder to decode the data into type T. And then, of course, we can call our completion handler with that now decoded data with our data model. So perform request looks like that. It's not too heavy or ugly looking. And now our call set actually looks significantly better. Actually, it looks pretty similar. But now our data is in some kind of form that we can like build collection views galore. Yeah, so similar. Now we just have a network operation of type array of bestsellers category. And now whenever we have a successful response, we can populate all the arrays or collection views that we want. So I was pretty happy that this reduces what our call set, or this improves what our call sets look like. Yeah. So this is what we've talked about today. I was pretty happy about this. But I also know that I gave the most simplistic example possible, probably, of a network request. I mean, it was a GET request. There was no body. There's no OAuth or anything like that. And I can assure you that we used a very similar network service in Coop. And we had a lot of extra things that were kind of like plug and play to make sure that it worked for us. And so I will give you some tips on what you can add in order to support different kinds of stuff. Okay, so leveling up your network stack. You can add a request adapter to your network service. This is specifically useful, or we used it in particular with if you need to do OAuth and you don't want to clutter up your API router with always adding your authorization headers to the request. You can just give the network service a request adapter, and then all of your URL requests can just get adapted with your authorization token headers. Similarly, if you're using OAuth and your tokens expire, sometimes you get back a response and you need to refresh your token. So you can add a retryer to your network service, which would handle those very specific responses and do the request retry for you. You can also use a custom URL session. I kind of didn't mention it, but the perform request function was actually just using the shared URL session. But if you have any need to have any kind of caching policies, or maybe you have certificate pinning enabled, then you can use a custom URL session for your network service. You can add custom decode options. You can add that either to your network service or to your network operation. It really depends on the level of granularity you want to have these decode options. We use them in particular. One of the API service, the original API service that we were talking to, always returned a 200 OK for any response. So, and if there was an error, we needed to like read the metadata field from the body of the response to get the actual error. So as you can imagine, we had like a different way of decoding because there was always this metadata field and then the real response body. And then our new API service had proper HTTP status codes coming back to us. And so we decided to go with this option of decoding those two kinds of responses in totally different ways by supplying a custom decoder. Also useful if your server returns a non-standard or like a non-standard date that JSON decoder can't read. And then, of course, API routers. In our case, we're using 2 different API services, so it was really nice to have those separated into 2 different API routers because all of the relevant requests from one API service lived in one router, and then for the other service lived in the other router. And I am happy to answer any questions if you have them. You can find me around the conference for the next 2 days. You can talk to me anything about network services, or you can tell me that I'm using enums in the wrong way. Or you can talk to me about React Native. I would actually love that if someone has any kind of these transition experiences from native to non-native. And yeah, I am Glenna, and you can find me on Twitter and GitHub. And if you want to see like the full working example from all the code that I presented, because there were some stuff that was left off, then you can feel free to find it on the GitHub.